Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is increasing and decreasing intervals. The idea of increasing or decreasing functions is related to having environments or intervals where the function is increasing or decreasing. A function will have different parts, some of them increasing or some of them decreasing. Now we will study these intervals using the derivatives. Let us consider the function. Here is the function f of x, which is equal to x square minus 4x plus 1. We want to study this function evaluating when it is increasing or decreasing, and for what that we must determine the intervals where the derivative is positive or negative. We can proceed in several steps. First of all, we are going to compute the derivative of f of x. So the derivative of f of x is denoted by f dash of x. So derivative of this is going to be 2x, applying power rule, and for this one, so derivative of this is going to be negative 4. Then we find the roots of this derivative. For that we impose f dash of x is equal to 0. Only then we can find the roots of the derivative. So set this equal to 0 and solve for x. Adding 4 on both these sides, you will get 2x is equal to 4, and dividing both these sides by 2, you will get the x value. X is nothing but 4 over 2, which is equal to 2. Therefore, the root is x is equal to 2. Hope you are clear with step 2. Now step 3. We established the intervals below and above the roots we have found, as well as any possible discontinuities. So in this case, we have two intervals. There are no discontinuities in this function f of x. Okay. Let us find the intervals. If you draw the graph, you can easily understand it. So for this one, you have to write two intervals. F of x should be, these are the intervals below and above the roots we have found, which is nothing but x is equal to 2. You have to write a symbol union in between, where the symbol we use is read as union. Now next step. Step 4. We choose a value belonging to each of the intervals, and we have to determine whether the derivative is positive or negative for the value we chose. So in this problem we can choose a number in between negative infinity to infinite, 2. So you can pick any number in between. Let me take 1. I have to replace x by 1 in this expression and check whether I am getting a positive or a negative value. If it is a positive, then we can say that the values are increasing. It is in the increasing interval. And if the value gives a negative number, a number which is less than 0, then we can say that the interval is decreasing. Okay, let me take one number in between, which is nothing but 1. So if I plug in that value, I am getting, so if I plug in 1 here, 2 times 1 is nothing but 2, 2 minus 4 is negative 2, which is less than 0, a negative number. It means the interval is decreasing, negative infinity to 2. Are you clear till this step? This is how we find whether the interval is decreasing or increasing. Now let us pick any one number in between this interval 2 and infinity. For example, we can take 10. So that's going to be a really good number. If you replace x by 10 in this expression f dash of x, and let's see what number we will be getting. So by replacing 10, you will be getting 16, which is a positive number, a number greater than 0. It means the interval is increasing, starting from this 2 to infinity. Namely, the increasing and decreasing intervals can be established. You can just mention this interval and write this interval as decreasing and this interval 2 to infinity as increasing. And it will be good if you mention the graph. So it will be very visible if you draw the graph and prove that the graph will be moving from left to right in a downwards manner, and on the other side it will be increasing. Since this is a quadratic expression, the graph will look like a U-shaped parabola. You can also notice the graph. Starting from negative infinity to 2, the graph is moving downwards. It is decreasing. And from this point 2 to the positive side, it is keeping on increasing. Does this make sense to you so far? Okay, let me take few more examples and explain you the concept. In the previous example, we just took a quadratic expression. Now I have taken another function. F of x is equal to x raised to 4 divided by x minus 2 the whole square. Now let's study its intervals. First, we need to find the derivative. So the derivative of this function is denoted by f dash of x. Here we have a numerator under denominator. So it will be good to apply quotient rule. Or you can just rewrite this as a product and also apply product rule. You can use the rule that you're very comfortable with. Now I am going to use the quotient rule and find the derivative. So f dash of x is going to be, hope you all know the quotient formula. Find the derivative of the numerator and keep the second derivative as it is. Write a negative sign in between, keep the first function as it is and find the derivative of the second function and divided by second function the whole square. Okay, so the derivative of the first function is going to be 4x raised to 3. Am I right? Because by applying the power rule. Keep the second function as it is. Write a minus sign and keep the first function as it is and find the derivative of the second function. You can apply the power rule for the second function, but please note that this is a function within another function. So you have to apply the chain rule. 2 times x minus 2. Derivative of x is 1 time. So multiplying anything by 1 is the term itself. So you need not mention it separately. Divided by square of the second function. Let's simplify this. You have to expand this using a minus b the whole square formula. And then you have to distribute 4x cubed with each and every term within the parenthesis. And here you can directly multiply 2 and x raised to 4. And then multiply this term with every term within the parenthesis. And the denominator is x minus 2 the whole. Okay. For this one, to make it easier, you can take this x minus 2 as a common factor out. Because it can be easily cancelled out with the denominator, no? So if you take that out, your distribution is going to be very simple. So if I do that, I'm getting, so far we have determined the first derivative of the given function f of x. Now you have to find the roots of the derivative. How we will find the roots? Yes, by setting f dash of x is equal to 0 and solving for y. So replace the left side of the equation by 0 and then solve for x. If you cross multiply, this term will vanish and then you can divide both the sides by 2. Only x raised to cube and x minus 4 will be left over on the right side. There you can apply the concept. Whenever a product is equal to 0, you can equate each of the factor to 0. Am I right? So by doing so, I can equate x cubed equal to 0 and x minus 4 equal to 0. So I'll get x is equal to 0 or x is equal to 4. So that those are the two roots. The intervals are constructed from the roots and the discontinuities. In this case, there is a discontinuity at x is equal to 2 because there is a denominator. Am I right? The denominator, if you set this denominator equal to 0, you will get one x value and that point is going to be the discontinuity. Please notice this. So that's the reason I took this example with a fraction. Okay. So in this problem, in this function, there will be a discontinuity at x is equal to 0. You can easily find the discontinuity with a fraction. I mean, if the fraction is a function, you can easily find the discontinuity. You can set the denominator equal to 0 and solve for x. So if I set x minus 2 equal to 0, I'll get x is equal to 2. So at that point, the graph will be discontinuous. Okay. You should know where the graph is discontinuous. So then it will be easy for you to find the intervals where it is increasing and decreasing. Okay. So x is equal to 0 and 4. Starting from negative infinity to 0 and 0 to 2 because it is discontinuous there. So this function has 4 intervals. You have to consider the discontinuity also while describing the intervals. Now you can choose any one number in between the limit in each of the interval and plug those values one by one in the f dash of x and then check whether you're getting a negative number or a positive number. Depending upon the sign, you can say that the interval is increasing or decreasing. Okay, let's pick some numbers in between each of the interval. Let us start with interval number 1. We choose values belonging to all of these intervals and we compute the value of its derivative. In interval 1, negative infinity to 0, I'm picking a number negative 1. So if I plug that number in f dash of x, I'll get. So you have to replace x by negative 1 in this expression. By doing so, I'm getting, if I simplify, I'll get negative 10 over 27. So that is a negative number. It means the interval is decreasing in this. Am I right? Hope you're clear so far. Now let's pick one number in the second interval. Let me pick in between 0 and 2, I can pick 1. So if I replace x by 1 in the f dash of x, I'm getting a positive number 6, which is greater than 0. So it means the interval 0, 2 is increasing. Now let's pick one number in between these 2 and 4. So for interval 3, I'm going to pick, let me pick 3 and plug in this expression f dash of x and check what value I'm getting. So if I replace x by 3, I'm getting negative 54, which is decreasing. Intervals are decreasing, increasing and decreasing. It is alternately changing. So let's check what will happen if we pick one number in between this 4 and infinity and check whether this interval is increasing or decreasing. 4, infinity. Can we take 5? Okay. So if I take x is equal to 5 and use that value, evaluate that in f dash of x, I'm getting a fraction, though it is a positive one. So this interval 4, infinity is increasing. In short, you can say that negative infinity to 0 is decreasing, 0, 2 is increasing, 2, 4 is decreasing, and 4, infinity is increasing. So all you have to do is find the first derivative, set that equal to 0 and solve for x. That will be your x root. And then you have to check whether there is any discontinuity or not. If there is no discontinuity, then it will be easy. If there is any discontinuity, then you will have more intervals. And you have to pick any one number in between the limit, the upper and lower bound, and then check that value in the f dash of x, not in f of x. And check whether the value is a positive one or a negative one. If it is a positive one, obviously the values are increasing. If it is a negative one, yes, the values are decreasing. So according to the sign, you can say whether the interval is increasing or decreasing. Hope you are clear with this concept. The steps are too simple and you can easily do this problem. In case if you get any query, you can let me know. See you in the next video. Have a great time.